Welcome to AMiNDR, a podcast where we summarize the latest publications on neurodegenerative disease research so that you can stay up to date with the newest findings. Every month, our team of scientists will sort and organize the titles into themes and present shortened versions of the abstracts. We'll make sure to mention the title, the journal, the first author, and the last author for each publication. Whether you're in the lab, on the bus, or cooking your meal, we hope you find this podcast helpful.
Hello and welcome to part 2 of the Imaging Tools for Diagnosis series for papers published in the month of June. My name is Bhumika and I will be your host for this episode. I hope you've all been keeping safe and socially distancing. If you haven't already, be sure to check out part 1 of this series. In this episode, I will be finishing up the detection and diagnosis category along with one other publication that I will get to in the very end. The AMiNDR team has been working hard on every single episode, and we hope you enjoy listening to them just as much as we enjoy making them. Be sure to have a look at the time-stamped bibliography for this episode to find all the papers we will be going over. I hope you're all cozied up and comfortable as we pick up where we left off in the detection and diagnosis category. First in this category we see a novel conversion prediction method of MCI to AD based on longitudinal dynamic morphological features using ADNI structural MRIs. First author, Guo. Last author, Hu, of the Journal of Neurology. This study introduced a cerebral similarity network with progression information to efficiently predict conversion from MCI to AD. New dynamic morphological features were defined to obtain sufficient longitudinal information. Based on these 3 features, the cerebral similarity network was built using a sparse regression algorithm with optimized parameters for efficient prediction performance. Training and evaluation of the classifiers was then conducted. The results showed an accuracy of 92.31%, 3 years ahead of MCI to AD progression. The author also established the efficacy of the dynamic morphological feature as a sensitive biomarker in the prediction of MCI conversion. You will notice that this category has multiple mentions of MRI and PET imaging techniques. The next paper is titled Brain 18F FDG PET Analysis via Intervalvalued Reconstruction, Proof of Concept for Alzheimer's Disease Diagnosis. From the journal Annals of Nuclear Medicine, first author Kocharczak, last author Mariano Goulart. The authors of this study propose a new approach for the 18F FDG PET analysis using an interval-valued reconstruction of 18F FDG brain distribution. Brain 18F FDG PET raw data of the subjects was collected and then reconstructed using an interval-valued algorithm, non-additive interval-based expectation maximization, also called NIBEM. Further subject classification was conducted using interval-based statistical comparison between cortical regions of interest or ROI. For comparative validation, PET images were post-processed using validated automated software. They based this on the computation of ROI normalized uptake ratios standard deviation or SUVRSD. The results showed distinct cortical ROI indices between AD patients and controls, along with statistically identical ROC curve areas for both groups. The sensitivity, specificity, accuracy, positive predictive value, and negative predictive value was significantly high at optimal threshold for both NIBEM and SUVRSD methods. Interval-valued reconstruction provides self-consistent brain analysis with effective diagnostic performance. Like mentioned in the first episode of this series, EEG and MEG technologies are like quarterbacks in the game of imaging tools, football, which will become clear as we continue exploring the next few abstracts. Let's talk about a novel connectome-based electrophysiological study of subjective cognitive decline related to Alzheimer's disease by using resting state high-density EEG EGI GES 300. From the journal Brain Sciences, first author Lazaro, last author Kujiumzi, This study explores the use of high-density electroencephalography, or HD-EEG, to study the brain network in the AD spectrum. 256 channels are employed to distinguish cognitive impairment in preclinical stages. A detailed neurophysiological testing along with a 10-minute resting stage HD-EEG was performed on patients with different levels of cognitive impairment. The authors obtained correlation matrices and established weighted undirected networks for calculating clustering coefficient CC, strength S, and betweenness centrality BC at global and local levels for each subject. There was a statistically significant difference in the local level CC between the 4 subject groups: AD, healthy controls or HC, mild cognitive impairment or MCI, and subjective cognitive decline or SCD. Local level CC was seen to be higher in the HC group as compared to the others, while BC displayed increase at local level but a decrease at global level as disease progression continued. SCD exhibits network disorganization with intermediate values between MCI and HC. The results indicate that disruptions in brain networks in parietal organization could be very useful in distinguishing people at early stages of the AD. This study also testifies to the use of 256 HD-EEG in network construction. Next up, we have large-scale structural covariance networks predict age in middle to late adulthood, a novel brain aging biomarker. This is from the journal Cerebral Cortex, first author Kuo, last author Lin. The authors of this study try to condense complex brain aging profiles into a single quantitative index. This index could potentially act as a biomarker in diagnostics and determining brain health. This study demonstrates the ability of a structural covariance network or SCN-based framework to predict an individual's brain age and features its clinical specificity for several disease populations. It was found that the most significant SCN for brain age prediction while balancing between model complexity and prediction accuracy included the caudate nucleus, putamen, hippocampus, amygdala, and cerebellar regions. A greater brain age disparity is observed in AD and schizophrenia patients compared to healthy controls. The results indicate successful brain age prediction from a brain network perspective and demonstrate the associated clinical feasibility of evaluating neurological diseases. Moving on, this next paper is titled A Combined Deep Learning and Lattice Boltzmann Model for Segmentation of the Hippocampus in MRI. First author, Liu. Last author, Yan. Journal, Sensors. A key step in the diagnosis and monitoring of diseases like AD is the segmentation of the hippocampus in MRI. The active contour model with a statistical shape barrier presents a few obstacles in the form of complicated registration of the shape prior, the target object, and of low efficiency. This study presents a semi-automatic model, which is a combination of a deep belief network, or DBN, and the lattice Boltzmann, or LB method, for segmentation of HC. The DBN training process consists of unsupervised bottom-up training and supervised training of a top-restricted Boltzmann machine, or RBM. The trained DBM can deduce the prior HC patient's specific shape when given an input image. This image is used to determine the initial contour and is introduced into the LB model to refine segmentation. The results of the proposed method show significant correlation and consistency with manual segmentation results. Now let's talk about deep learning, a successful tool in constructing brain imaging signatures of normal brain aging, as well as identifying those of various brain diseases like schizophrenia and AD. This paper is called MRI Signatures of Brain Age and Disease over the Lifespan based on a deep brain network and 14,468 individuals worldwide. From the journal Brain, first author Bashyam, last author Davatsikos. This study developed and tested an advanced deep brain network, deep brain net, using a large set of MRI scans from an extremely diverse cohort. The tests performed used cross-validation. A separate replication cohort indicates that Deep Brain Net can derive brain age estimates without specialized image data preparation and processing. The results of this study show that moderately fitting brain age models provide estimates that are more discriminant of individuals with pathologies in the 4 disease groups tested as compared to the more commonly used tightly fitting models. Accurate brain disease classifiers can be constructed by using deep brain net with transfer learning. The authors successfully developed a domain-specific deep brain network which could reduce the need for application-specific adaptation and tuning of generic deep learning networks. Next up, we have Imaging the Aging Brain, Study Design and Baseline Findings of the Senior Cohort. Journal, Alzheimer's Research and Therapy. First author, Hager. Last author, Botlander. The senior study aims to establish integrated multiparametric maps of normal aging and the identification of early biomarkers for neurodegeneration. The authors of this paper described the senior study as a longitudinal observational study of 142 healthy elderlies being followed annually for 10 years to understand physiological aging and its conversion to neurodegeneration. The proposed multimodal protocol includes structural, diffusion, functional, and sodium MRI, PET, blood samples, genetics, audiometry, neurophysiological and neurological examinations, and an assessment of neuronal risk factors. The baseline results obtained reveal that cerebral white matter lesions can be predicted by cardiovascular and cognitive risk factors and age. There was a strong link between cardiovascular risk factors and juxtacortical and periventricle lesions. Intra-subject across-test variability is a measure of neurophysiological performance and a prospective cognitive marker which can predict white matter volume. Intra-subject across-test variability, volumes, and cortical thickness show stark differences when the cohort is divided into subjects with higher and lower risk profiles. The results clearly show the influence of intra-subject across-test variability, age, gender, and risk factors on neuronal decline as indicated by structural features of the brain. Coming right up is behavioral psychological symptoms of dementia and functional connectivity changes, a network-based study. First author, Sarah. Last author, Bozali. Journal, Neurobiology of Aging. Early-stage AD is often accompanied with behavioral and psychological symptoms of dementia, also called BPSD. This resting state functional MRI/RS FMRI study analyzes functional brain network alterations in AD patients presenting BPSD at different clinical stages. The AD patients in this study underwent a neurophysiological evaluation including Neuropsychiatry Inventory 12, NPI-12, as well as the 3T MRI with healthy controls, or HC. 5 principal factors were extracted from NPI-12, and RS FMRI data was processed using graph theory to study functional connectivity. 62% of the patients showed BPSD and brain network connectivity changes. This paves the way to new non-pharmacological interventions to modulate brain connectivity and improve patients' BPSD. Moving right along, we have multi-scale ATUM-FIB microscopy enables targeted ultrastructural analysis at isotropic resolution. First author, Kisslinger. Last author, Schaefferer. From the iScience Journal. The authors of this study propose ATUM-FIB, a hybrid method which combines the large field of view of ultramicrotomy techniques like ATUM or SSTEM and the isotropic voxels of ion beam milling approaches like FIB-SEM. ATUM-FIB operates through serial sectioning of tissue into semi-thick sections collected onto tape which represent a tissue library. This provides 3-dimensional context information that can be further studied using local high-resolution analysis. Regions of interest were identified and made accessible for target FIB-SEM. This study reveals the ability of ATUM-FIB to divulge the ultrastructure of rare but pathologically important events by identifying microglia contact sites with amyloid plaques in a mouse model of familial Alzheimer's disease. I actually found that abstract very interesting to myself. That paper actually made its way into my to-read list as well. Next up is the role of resting state network functional connectivity in cognitive aging. First author, Hausman. last author Woods, from the Frontiers in Aging Neuroscience journal. Aging is closely linked to disruptions in the resting state functional architecture of the brain. The mixed findings of previous studies have failed to clarify the link between resting state functional changes and cognitive decline in healthy adults. The authors of this study explore the impact of intranetwork coherence for 4 higher-order cognitive resting state networks on a measure of cognitive aging. The coherence within the singular opercular network, or CON, was significantly associated with the fluid cognition composite scores. The CON connectivity was mapped onto fluid cognitive subdomains, and greater CON connectivity was linked with enhanced performance on episodic memory, attention, and executive function tasks. This supports the potential use of CON coherence as a neural marker for non-pathological cognitive aging. Alright, so this might be good time to stretch a little bit and grab something to drink. Moving along into a machine learning approach for the differential diagnosis of Alzheimer's and vascular dementia fed by MRI selected features. First author, Castellazzi. Last author, Gandini, from the Frontier in Neuroinformatics journal. Alzheimer's disease, or AD, and vascular dementia, or VD, have similar neurological symptoms. Machine learning, or ML, used in conjunction with MRI, has shown to have improved diagnostic accuracy for neurodegenerative diseases. This study explored the use of the Artificial Neural Network, or ANN, Support Vector Machine, SVM, and Adaptive Neurofuzzy Interference Systems, ANFIS, categories of ML algorithms combined with advanced MRI features in distinguishing VD from AD. The authors also investigated whether this approach could predict the prevalent disease in subjects with mixed AD-VD dementia, or MXD clinical profiles. The algorithms were trained using multiple regional metrics from resting state FMRI and diffusion tensor imaging as input features in order to find the best feature patterns to classify AD from VD. The identified VD-AD discriminant feature pattern was used as input for the most performant ML algorithm to predict disease prevalence in MXD profile patients using their baseline MRI data. On comparing ML predictions within the 3-year follow-up diagnosis evidence, ANFIS was observed to be the most efficient algorithm with classification accuracy greater than 84%. ANFIS showed increased classification accuracy when trained with a multimodal input feature. The results showed that the proposed approach has a high discriminant power to classify AD and VD profiles with potential to efficiently predict the prevalent underlying disease in dementia patients whose clinical profiles are uncertain. The next paper is titled Medial Temporal Atrophy in Preclinical Dementia, Visual and Automated Assessment During 6-Year Follow-Up. First author, Martinson. Last author, Westman. Journal Neuroimage Clinical. The goals of this study were to characterize the longitudinal progression of medial temporal lobe (MTL) atrophy in individuals with subjective cognitive decline and MCI tracked over 6 years, and to determine the ability of clinical rating scales to detect these changes. The MRI images were visually rated according to the Shelton scale. Additionally, the images were segmented using FreeSurfer's longitudinal pipeline to compare the MTL ratings to volumes of the hippocampi and inferior lateral ventricles. The results indicated that MTL atrophy rates increased with CSF biomarker abnormality and that visual rating scales are a valid substitute for automatic segmentations. It was also observed that an increase of MTA score by 1 took over 8 years for MCI and AD profile patients. It was concluded that MTA ratings were too coarse for tracking individual MTL atrophy in short time spans. The subjective nature of the assessment is the key constraint quantifying MTL atrophy with visual ratings. The next paper talks about mice. Although not the Mickey and Minnie kind that you probably enjoyed as a kid. Diffusion MRI detects early brain microstructure abnormalities in 2-month-old 3TG AD mice. Let's see what first author Falangola and last author Jensen of the NMR in Biomedicine journal have to say. The 3TG80 mouse model exhibits Alzheimer's disease pathology similar to humans, making it one of the most studied animal models of AD. In the past, Diffusion MRI have evaluated white matter abnormalities in 3TG80 mice with inconsistent results. This study probes into the sensitivity of DMRI in capturing microstructural changes in 2-month-old 3TG80 mice. It was observed that the fractional anisotropy, FA, kurtosis fractional anisotropy, KFA, and radial kurtosis, or K-uptake values was significantly lower in 3TG80 mice compared to the controls in the fimbria. However, an opposing trend was seen in the mean diffusivity, MD, and radial diffusivity, or D uptake values. Whereas the 3TG80 mice showed lower K uptake in the fornix, they found elevated MD and D uptake in the dorsal hippocampus and elevated FA, MD, and D uptake in the ventral hippocampus. These results indicated that DMRI can successfully detect early brain morphological abnormalities in 2-month-old 3TG80 mice. The next paper is Pre-trained MRI-based Alzheimer's disease classification models to classify memory clinic patients. First author, DeVos. Last author, Rombouts, from the NeuroImage Clinical Journal. The authors of this study trained MRI-based AD classification models on a dataset with AD patients and controls. The model was then used to subsequently assign AD scores to subjective memory complainers, or SMC, MCI patients and AD patients from a multi-center memory clinic dataset. The anatomical MRI, diffusion MRI, and RS FMRI scans were then used to calculate multiple key aspects of the brain. On average, all the models assigned AD patients with the highest AD score, followed by MCI patients and then SMC patients. The anatomical MRI models had the best performance, with gray matter density being the best performing measure, showing high AUC indices while distinguishing between the subject groups. The diffusion MRI models did not generalize well to the memory clinic data, while the functional connectivity model successfully separated SMC subjects from MCI patients. The multimodal MRI model did not enhance the anatomical MRI model. These results indicated that the gray matter density model generalizes best to memory clinic subjects. The next abstract was short and sweet. Bayesian and influence function-based empirical likelihoods for inference of sensitivity in diagnostic tests. First author, Hai. Last author, Kien, from the Statistical Methods in Medical Research Journal. Current methods to study sensitivity of diagnostic tests include normal approximation and empirical likelihood, or EL-based approaches, which tend to have poor performance for high specificity. To overcome these hurdles, this study proposed influence function-based empirical likelihood methods and Bayesian empirical likelihood methods. Numerical studies were conducted to compare the performance of the proposed approaches with existing methods. The proposed methods showed better performance in terms of coverage probability and interval length. Moving along, automated white matter hyperintensity segmentation using Bayesian model. First author, Fifford. Last author, Barnes, of the Neuroinformatics Journal. This study assessed the Bayesian model selection, or BAMOS, a model selection framework for white matter hyperintensity WMH segmentation. BAMOS segmentations were compared to semi-automated segmentations. Further evaluations were conducted to check whether they could predict longitudinal cognitive change in control, early MCI, late MCI, subjective memory concern, or SMC, and AD patients. MRI images from controls and AD patients were selected to incorporate multiple scanners and were semi-automatically segmented by 4 raters and BAMOS. The segmentations were then evaluated against multiple parameters. Cognitive change was the observed outcome of linear mixed effect models, and a range of predictors were used. A significant agreement was seen between BAMOS's WMH segmentation volumes and a consensus of rater segmentations. BAMOS WMH effectively used MMSE, Clinical Dementia Rating Scale, and Alzheimer's Disease Assessment Scale Cognitive Subscale to predict cognitive changes in various subject groups. It was concluded that BAMOS compares well to semi-automated segmentation and generates volumes which predict decline. Next up is Hubs of Long-Distance Co-Alteration Characterize Brain Pathology. First author, Corda. Last author, Costa, from the Human Brain Mapping Journal. Co-alterations are becoming increasingly convincing representations of brain disease impact as compared to local alterations. The authors of this study calculate the meta-analytic transdiagnostic networks of co-alteration for gray matter changes and assess the mean Euclidean fiber length and topological node distances. The proportion of co-alterations between canonical networks and transdiagnostic variants of Euclidean distance were investigated. More target analyses were conducted on schizophrenia and AD. The disease-specific analyses demonstrated that long-distance co-alterations effectively identify areas involved in pathology and symptomatology. The results of this study prove the network degeneration hypothesis in brain pathology and suggest the adequacy of the co-alteration concept for clinical neuroscience. The last paper to round up this long category is Resting State FMRI Analysis in Apathetic Alzheimer's Disease. First author, Buyu Kok. Last author, Gervid, of the Diagnostic and Interventional Radiology Journal. Apathy often appears with AD and leads to an increase in daily functional loss. This study shed light on the neuroanatomical correlates of apathy in early stages of AD using task-free functional MRI. Patients with a history of progressive cognitive decline were recruited in keeping with their clinical dementia rating. The patients were divided into apathetic and non-apathetic AD subgroups, and a control group was also involved. The participants underwent structural and functional MRI, and the resting state condition was recorded. The distinctive feature between the three groups was the pregenual anterior cingulate cortex, or PGACC, with the apathetic AD group showing the highest constriction in the area. The region around the PGACC seems to mediate motivation to initiate behavior and weaken thereafter as the apathy becomes more severe in AD. This next paper was a stray and didn't quite seem to fit into any of the previously discussed categories, but is still extremely relevant to the imaging tools for diagnosis theme. It's titled, Intermethod Reliability Between Automatic Region of Interest Analytic Application with Multi-Atlas Segmentation and Free Surfer. First author, Utsumi. Last author, Shigeru, of the Psychogeriatrics Journal. Previously used for detecting hippocampal atrophy, MRI developments in segmentation techniques gave way for fewer errors and a multi-atlas approach. T-Proto is an automated region of intelligence or ROI analysis application with multi-atlas segmentation, joint label fusion, and corrective learning to support the clinical applications of MRI advances. This study assessed the reliability between T-Proto and FreeSurfer, a reference ROI analysis software. MRI data from a set of AD patients was collected, and the intermethod reliability was evaluated in terms of the intra-class correlation coefficient, or ICC. Most of the estimated volumes using T-Proto was smaller than the ones estimated using FreeSurfer. It was also observed that regional ICC between the two methods indicated moderate to high reliability. It was hence concluded that T-Proto was more reliable in the hippocampus than FreeSurfer. And that is a wrap. Thank you so much for listening in. We hope you found this information useful. Keep an eye out for many exciting new episodes coming your way. Have a great day, and we hope to have you back soon. See ya!
That's it for this episode. A huge thank you to the team that is working on sorting, summarizing, and scripting these abstracts, as well as the operations behind AMiNDR. The music is from Journey of a Neurotransmitter by Anusha Kamesh, musician and fellow scientist, and now member of the AMiNDR team. You can find the original piece and her other music on SoundCloud under Anusha Kamesh or on her YouTube channel, AK Music. Interested in joining the team? Give us a shout! We can always use help with content development, podcast editing, advertising. and you can be part of a new and exciting venture. Reach us by email at aminderpodcast@gmail.com or follow us on Twitter. Oh, we're also on Facebook now. Don't forget to subscribe to our mailing list if you want access to the bibliography for each of our episodes. The references come with timestamps. Timestamps. So you can more easily locate the paper that caught your interest. Check our notes below for details on how to sign up. And very close to this, you'll also find a link to our feedback survey. Because, yeah, your feedback matters to us. So please, pretty please, let us know how we can make this podcast a better tool for you. And last but not least, thank you for tuning in with us. And on this note, we hope you found our podcast useful and accessible. Until next time.